In this session, we'll be configuring Active Directory integration so that ISE can refer to Active Directory to look up and validate user objects and credentials as well as group names. To start off here, we'll take advantage of the Work Center as it provides some nice easy links and information helpful to the task at hand. In this case, we're adding an external identity store. Note that ISE can be its own identity store for many purposes, users, groups, and the like. One exception would be the use of validating an endpoint ID certificate. ISE is currently not able to authenticate using certificates from endpoints. But other than that, ISE can be used for many things as an internal identity store. In this case, Active Directory will be external. Let's go ahead and add that. See the list of possible external identity sources that can be provided. Active Directory is the first one on the list there, and we'll do an add. In this case, we're given two fields to fill out. The first one is called the join point name. In this case, this is just a descriptive label that ultimately will be added into the ISE dictionaries and available for policy building. So as we look at the Condition Studio later on, that this is the value that we'll see listed here. If needed, this name can be changed subsequent to adding it here. If we decide that we have a better label or other domains that need to be added and distinguished better, we can change that. And then this is the actual domain name, not the domain controller itself, but the domain name. And this was the official, needs to be name resolvable domain name. ISE needs to be pointing to a DNS server that can resolve this name to a set of DCIP addresses and SRV records and the like. We'll submit that. Gives us the opportunity to join all ISE nodes to the Active Directory domain. So in the case of a multi-node deployment, that is a nice convenient shortcut. And here, prompting us for credentials, what we need to supply here are credentials sufficient to being able to add a computer object to the domain. And one thing that we should point out here is that ISE becomes a full domain member subsequent to this operation. Additionally, to get somewhat more creative, we can place the ISE computer object into a particular OU within the domain. It won't create this OU, but we can add it and make it distinguishable from the rest of the computer objects that are probably in the domain as well. Gives us a quick validation that the ISE node has been joined to the domain. Now against this, and can be done at any particular point, if we suspect there are issues with communication from this node towards Active Directory, we can run diagnostics. We'll go ahead and run all tests now, and we'll give a very thorough interaction with that domain and related domain controllers and verify everything's operating properly. Notice that with this drop down, that we could select particular nodes to run this diagnostic tool from. Ultimately, in a distributed deployment, it's the PSN nodes or policy service nodes that will need to be able to interact directly with the domain for network reachability and what have you. In this case, be aware that the full suite of ports are needed to be able to interact with the domain, and then likewise we don't want to have any network translation policy in the way of the ISE node that needs to interact with the domain controller, that no network translation should be taking place there. If we can go back to our demo.local, in addition to the domain join point name itself, we'll want to add other objects to the dictionary to support policy building. In particular, user groups. And here we can do an add. We can add our own information. It's better to take advantage of browsing into the domain and retrieving those group values. In this case, the default filter has been left to all, so we're seeing a substantial amount of groups in this list, many of which won't ever be utilized for ISE policy building. So let's reduce the size of this list and look at globally distributed objects and retrieve once again. And here we get a shorter list. Let's go ahead and select all and then deselect some that we know that we won't be using. We won't need the DNS update proxy. We won't need domain controllers, but we do want domain computers. We won't take advantage of domain guests. We won't take advantage of group policy creators. And we won't take advantage of read-only domain controllers. So understand now what's happening here is we're importing these group objects into the ISE dictionary where we can now use them for policy building. And it's also important to note that this is more than just a name that's being matched and validated against information being retrieved from the domain controller from the domain itself. Notice the SID values are the more specific match. If we need to modify this list later on, we can remove groups from the list or of course add to them by redoing this operation. If new groups have been added subsequent to this, we can add those groups. In addition to the groups, we'll also want to add some specific object attributes, and we'll search on the directory, in this case for a particular user and user related attributes. Yeah, and there's a variety of attributes within any particular object that could be useful for policy matching. In this case, we'll monitor bad password count. We can derive policy around how many bad password attempts have been attempted so far. And down at the bottom of the list, the user principal name we're wanting to match. And so now again, similar to the group objects, these attributes for the user object are now also added to our dictionary for policy building on ISE. And we'll save that. That's what should save both the groups and the attributes, and we get a success message back. Now if we go back to the connection, notice one of the other things that we can do here is test user access. ISE is a great platform for this kind of activity, that as opposed to trying to get out into a network and validate that the whole authentication loop is occurring, that we can check those concepts and reachability and validation of authentication to that domain right here. We'll modify the test that we're doing by performing a user lookup first, and although we effectively already did this by looking at the attributes for employee 2, we see that we were able to retrieve those successfully, have additional information. Again, these values that are effectively retrieved along with the authentication success, in this case just a lookup, we also can utilize any of these values for policy building within ISE. Let's try that again here with Kerberos. And this time we're requiring a password. Let's test the full credentials. And here we see success, so credentials are matched and valid, and we see a little bit of the interaction time between our node that, in addition to PAN and M&T, is also acting as a PSN, and how long it took to retrieve this information. And then last, we'll try interaction with the remote procedure call, and we see successful interaction with that in basic authentication timers. These are valuable when we consider overall latency between users and portals and whatnot, that this would be a value in addition to that latency retrieval time from the Active Directory domain. Here we went through very briefly joining ISE to an Active Directory domain. Once again, ISE becomes a domain computer object within the perspective of the Active Directory domain itself, and this allows us to derive access to our users via Active Directory, and of course additional information being obtained by the mirror interaction. Group objects as well as specific user attributes can all be taken advantage of within policy on ISE.